So I just want to do one more example of how I would use the arc length formula. So let's just take, this one's maybe not so, not quite as simple as a linear function. Let's look at 1/4 x squared minus 1/2 natural log of x. And we want to look along the interval from 1 to 2e. All right. So the first thing, recall that our arc length formula, we're going to integrate from 1 to 2e, and we're going to take 1 plus the derivative of the function squared. That will be our integrand. Take the square root of that, and that's what we will integrate. So the first thing here is to find the derivative of this function. So y prime, so that's going to be 2 times 1/4, which is 1/2 x, minus 1/2 times the derivative of natural log, which is 1 over x. So that'll just give me 1/2 times 1 over x, which I can rewrite this as x over 2 minus 1 over 2x. All right, so there's my derivative. Now I need to square it. So I'm going to have x over 2 minus 1 over 2x times x over 2 minus 1 over 2x. So let's just FOIL this out. That's going to, the first terms are going to give me x squared, x squared, getting ahead of myself, x squared over 4. And in the outer term, that's going to be x, so minus x over 4x. And then the inner term is going to give me the same thing, x over 4x. And I'm going to have a plus 1 over 4x squared. So let's try to simplify this a little bit. So notice that this right here, I've got x over 4x. So that's just going to be 1/4, and I have another 1/4 here, right? That'll be 1/4. This will be 1/4, so I'll have minus 1/4 minus 1/4. That's going to give me minus 1/2. So I have x squared over 4 minus 1/2 plus 1 over 4x squared. So that's this piece right here. That's my derivative squared. Now I need to add 1 to it. So if I just add 1 to this, then I'm going to end up with x squared over 4 plus 1/2 plus 1 over 4x squared. All right, so now we are ready to put that underneath the radical and integrate. So I have integral from 1 to 2e, the square root of x squared over 4 plus 1/2 plus 1 over 4x squared. All right, now you could, the way this is written, this is why you have kind of this weird upper bound 2e. There actually is a way that you can factor this so it becomes a perfect square, and then you take the square root and then you integrate that, and it's, you know, easy to do by hand. But in general, this formula is going to result in integrands which are messy at best to do by hand. In some cases, they're going to require techniques that we don't know, or things that, you know, that are not able to be done by hand. So for this section on arc length, it's fine if you just want to take this and put it into your calculator. And in fact, that's what I did. And if so, if you put this in correctly and put in your bounds correctly, then you should get something very close to 8. I got 7.99. Okay, so that's it for arc length. There'll be some applications that we'll discuss in class, but I just wanted to go over in this lecture how we derive this formula for arc length, and then also just a few examples of how we use the formula.